The question says simplify this subject expression. Okay, so we have 1 over root 2 plus 1 over root 3. Okay, everything in the parentheses squared. So how do we do this? Solution. So here we have 1 over root 2 plus 1 over root 3. Okay, so everything squared. Okay, so we can apply this algorithm. Okay, so we have this identity. How do we expand this when we are squaring addition? Okay, so we square the first one, a squared. Okay, we look for the product of this, multiply it by 2, so we have ab times 2, and we square the last one. Okay, so let us apply this to this. So for the first one, 1 over root 2, that represents a. Okay, 1 over root 3, that represents b. Okay, so let us apply this to this. So for a squared, which is 1 over 2 squared, 1 over root 2 squared, so we say 1 over root 2, okay, squared plus, we have 2. So for ab, we have to multiply ab, so that is 1 over root 2 times 1 over root 3, okay, plus, so for b squared, we have this as b, so we have 1 over root 3 squared. Okay, so let us simplify this further. So for 1 squared, we have it to be 1, okay. For root 2 squared, we have that to be 2. How do we get that? So for root 2, it seems as saying 2 raised to power half, okay. So when we square this, so we have this as this. So when we apply the exponent's law, this will multiply, half will multiply this. So by half multiplying this, we have this as 2 over 2, okay. So for 2 over 2 is 1, we have this as 2. So for 2 squared, we have it as 2, okay. So plus, here we have this as 2. It's multiplying the product of this. So we have this as 1 divided, for root 2 times root 3, we have it to be root 6, okay. Plus, for square of 1 is 1, okay. For root 3 square, the same thing applies to this. So we have this as 3, okay. So when you simplify further, we have this as 1 over 2 plus, so 2 we multiply this, so 2 times 1 is 2 over root 6, okay, plus, here we have this as 1 over 3, okay. So when we look at this, we can combine this and this, okay, together, okay, or let's start with this. Since we have 2 over root 6, okay, so to eliminate this, the roots, we rationalize by multiplying by root 6 over root 6, okay. So when we do that, we multiply this with this, we have 2 root 6 divide, since we are multiplying the same roots, we pick out 1, okay. So we can simplify this further, so we have root 6 divide, so this is 3, so we replace this with root 6 over 3, so here we have this as equals 1 over 2 plus root 6 over 3 plus 1 over 3, okay. So we can use the LCM approach to simplify this further. So for the LCM of 2, 3, and 3, we have this to be 6, okay. For 2 and 6 is 3, multiplied by this, we have 3 plus, okay. For 6 divided 3, we have it to be 2, multiplied by 2, we have this as 2 root 6, okay, plus, for 3 and 6 is 2, multiplied with this, we have this to be 2, okay, sorry, so we have this to be 2, so when we divide 6 by 3, we have it to be 2 times 1, that gives 2, so our final result, we add this to this, okay, 3 plus 2 is 5, okay, plus 2 root 6, which is this, divide 6, okay. So this is the first method we can use to approach it. So let us try another method. Let us start by working with Okay, let's work with 1 over root 2 separately. Let's work with 1 over root 3 separately. Okay, so let us say method 2 to approach this. Okay, so we have this as 1 over root 2, okay, plus 1 over root 3 squared. Okay, so we have this as method 1. We arrive to this answer. So let us approach this with method 2 to see whether we get this answer as well. So for 1 over root 2, okay, so let us rationalize it individually. So for 1 over root 2, we have this as root 2 over 2. We rationalize this. How do we do that? So we have 1 over root 2 times root 2 over root 2. We are doing that to eliminate this root, okay, the denominator. So here we have this as 1 times root 2 is root 2 over, multiplying the same sort we make out 1, so we have root 2 over 2, okay? So that is for that. So plus, so let us rationalize this part as well. We have 1 over root 3, this implies root 3 over 3, okay? So we square our results, okay? So when we do that, we can now apply this identity, okay? We represent this as A, okay? We represent this as B, this part, okay? So for addition of A plus B, which is this, okay? Since we are squaring, so we have A squared, okay? That is root 2 over 2 squared, okay? Plus, so the product of AB, the product of this, okay? We multiply the result by 2. So when we say 2, okay, so we have root 2 over 2 times root 3 over 3, okay, plus the square of this. So we have this as root 3 over 3 square, okay. So that is step 2, okay. So from here, so let us open up. Okay, as a result of this square, it affects both the numerator and the denominator. So for root 2 square, so we have it as 2. Okay, how do we get 2? So when we say root 2 squared, so for root 2, we can have it as 2 raised to the power half, okay, squared, okay. So when we apply the exponent rule, multiplying these 2 power, okay, it will be 1, half times 2 is 1, so 2 raised to the power 1 is 2. That's how we get that 2. So for root 2 square is 2 over 2. So for this 2 square is 4, okay, plus 2, which is this. So in the parentheses, we multiply root 2 times root 3 is root 6, okay, divide 2 times 3 is 6, okay, plus, so for root 3 square is 3, divide, for 3 square is 9, okay. So from here, we can simplify this 2 over 4 as 1 over 2, okay, when you reduce this further, plus, so we multiply 2 with this, so this can simplify, 2 here 1, 2 here is 3, okay, so we have this as root 6 over 3 plus 3 over 9, okay, sorry, we can reduce this as 1 over 3, okay. So when we look for the LCM, that is 6. So in 6 is 3, when we multiply this we have to be 3, okay. 3 in 6 is 2, multiply with this we have 2 root 6, okay. Plus, when we divide this with this, we have 2, multiply this with 2, we have this, okay. So when we combine this with this, 3 plus 2 is 5, plus 2 root 6 over 6, okay. So we have the same answer. Thank you very much.